Well, hello there. Welcome to your online science lesson. I know what you must be thinking. Oh gosh, I'm really so tired from learning in school and now I have to learn online. Well, guess what? I'm tired from teaching online too. So, why don't we make ourselves a sugary drink to re-energize ourselves before we learn about today's topic, chromatography. Let's go. And this is my lovely kitchen. Today, I'm going to take sugar and I'm going to stir it and dissolve it in water. After I stir and stir, I'm going to get a clear substance on the right of your screen. Now, do you know the technical names for these three things? Sugar is known as the solute. Now, the solute is a substance that dissolves. And what does it dissolve in? Water, which is the solvent. And finally, by stirring, I obtain this thing called a solution. I wonder if you remember these concepts. And the most important one, how much sugar actually dissolves in the water? Well, the name for that is solubility. So solubility is the degree to which a substance dissolves in a solvent to make a solution. But I bet you're thinking, something is not right here. Why would I drink just sugar and water? That doesn't taste nice, and I don't think it's going to give me enough energy to power through this online lesson. You know what? Let's not drink this sugar solution. Why don't we opt for an energy drink? But there's a small problem that I have here. You see, when I look at the contents of the energy drink, some parts are kind of blanked out, and I am allergic to a few substances. So how do I know if this energy drink contains substances that I might be allergic to? What if I get an allergic reaction and I pass out without finishing this lecture? Oh no! Well, not to worry, because science is coming to the rescue. So how can we find out what are the components of the mixture like my energy drink? Well, after going through paper chromatography, we'll obtain this result called a chromatogram. Now as you can see, the chromatogram contains one side where it has my unknown substance as well as a whole long list of known substances, and by comparing the dots on the chromatogram, we will know exactly what substances are inside this energy drink and whether I can drink it or not. So this is the process called paper chromatography. It is a technique used to separate the mixture based on how soluble different components are in the mixture. So you can think of it like a race car. The more soluble a substance is, the faster the substance will travel up the chromatogram. Here we have a piece of chromatography paper and we are going to prepare it to undergo the process of paper chromatography. Step 1, we are going to draw a start line in pencil. Why do we draw in pencil? Because pen ink is soluble in the solvent and it might corrupt our results. Step 2, we are going to place a spot of ink, not too much, not too little, just a small dot on the chromatography paper. Now why don't we put a bigger dot? Because the spot cannot be too big or else it might overlap with our other results and then our entire chromatography process might fail. Oh no! Step 3, we are going to lower the paper into the solvent. Now when we do so, the solvent has to be below the start line. The start line should be above the solvent so that your dot will not dissolve into the solvent but rather raise up the chromatography paper and give us a nice beautiful chromatogram. Here is the experimental setup for chromatography. As you can see, as the solvent travels up the chromatography paper, so will the ink spot. Remember our race cars? Here they go. The different dyes in the ink mixture will travel at different rates up the paper, and when chromatography is finally complete, we will see this ink dye separate into various parts. When we are done with the process of paper chromatography, the end product should look something like this. Notice how the solvent has moved past the start line and go all the way up towards the edge of the chromatogram. And you can see on the chromatogram 3 different spots that separated from our little spot of ink. Here is another diagram to remind us that the pencil line should be above the initial solvent level. And finally, we can see the solvent front towards the end of the chromatogram. But teacher, why should I learn about paper chromatography? What on earth can I use paper chromatography for? Well, paper chromatography has a wide variety of applications, starting with the beautiful chromatography bookmarks that you're going to try making later, to more scientific applications like finding out what exactly are the components of this unknown mixture or unknown substance that we have, to even in sporting events or in healthcare where we use chromatography to test for drugs and other substances in our urine. So why would we use paper chromatography? Now let's imagine you are now testing a bunch of athletes before a race to see which of them has used performance enhancing drugs. And to do that, we are going to send all their urine samples and pass them through the process of paper chromatography. Firstly, the advantage of paper chromatography is that it is fast and it will give you the results, as you will see later on, within a matter of minutes. Now, secondly, only a small sample is needed for us to undergo the process of paper chromatography. Now, imagine if you tell your athletes that they need to produce 3 liters of urine before they can be certified for the race. I think they're going to dehydrate halfway during the run. Isn't that right? So, 2 advantages. Paper chromatography is fast and only requires a small sample. Now, paper chromatography can be used to identify components of a mixture as well as to test for purity. Because if your chromatogram has only one spot, there's only one substance inside your mixture, that makes it a pure substance. Let's extend our learning. What happens when the components of my mixture are colorless? How on earth am I going to see colorless substances? Let's take 5 seconds to think about it. If your answer is we need to find some way to make the colorless substances colored, you are right. Ding ding ding. We use this thing called a locating agent, which will react with these colorless substances, thereby making them colored and visible. After that, we can compare away on our chromatogram. Now, another way to do it is to use things like ultraviolet light, UV light, that will allow us to see substances that we otherwise cannot see with our naked eye. Well done, my fellow science explorers. We have now come to the end of this section of the online lesson, and you are now equipped with all the skills and principles you need to conduct your own paper chromatography. Now watch the next video for instructions on the practical to create your own paper chromatography bookmark. Good luck, all the best, and bye-bye!